Okay, let's work this other example. Okay, in this case, they gave us the directions of the currents. We don't have to choose them. So we have I1, I2, and I3. Now, we are given the values. So the next step is to identify the pluses and the minuses. For the batteries here, they also did that for us. For the resistor, so for R1, plus is where I1 comes in, minus where it comes out. For R2, plus where I2 comes in, minus where it comes out. For R3, plus where I3 comes in, minus where it comes out. The next step is to write the voltage drop across each of the resistors. For R1, it's going to be R1I1. For R2, it's R2I2. For R3, since the current through it is I3, it's R3I3. Okay, we did these steps. Now, we are going to have to identify our loops and then proceed like we did in other examples. Okay, I'm going to choose another color for the loops. Okay, let's go green. So if I start here, I'm going to go counterclockwise this time to come back here. So as I go around my loop, okay, let's choose the purple. So the first thing I meet is the minus of R2. So it's minus R2I actually. So I go from minus to plus, so it's an increase in voltage, so it's plus R2I2. And then we meet the plus of R1, so I have a voltage drop, so that's going to be plus, so I go from plus to minus, so it's a voltage drop, so it's minus R1I1. And then I go from plus to minus, so it's another drop, so it's minus E1 is equal to 0. Okay, so again, met R2I2, met the minus, went to the plus, so it's plus R2I2. Then here I met the plus, so it's a voltage drop, minus R1I1. And then I met the plus, so it's a voltage drop, minus E1. And we are back where we started. Okay, now let's do another loop. The other loop, let's do it in green like we did the other one. Let's do the big loop this time, just to show different things, to try different things. Okay, I'm doing it counterclockwise as well. Okay, and then, like we did before, actually let's choose another color. Let's go red this time. So going from here, first thing I meet the minus of E2, so it's going to be from minus to plus, so it's an increase, so plus E2. And then here we met the minus of R3, so it's again an increase in electrical potential, so it's plus R3I3. And then we are here, we met the plus of R1, so it's going to be a decrease in electrical potential, so it's going to be minus R1I1. And then here we met the plus of E1, so it's a decrease in electrical potential, so it's minus E1. And we are back where we started, so this is equal to 0. Now we are done with this. We write in black, we are going to write the junction rule. I'm going to write it for this point. In this case, all currents are coming out of that point. We don't have any incoming. So sum of I in is sum of I out. And in this case, that's going to be I in is 0 and I out is going to be I1 plus I2 plus I3. That's my third equation. Okay, I'm going to plug in the numbers. Let's go back to purple here for the first equation. So R2I2, so it's going to be 150 ohms I2 minus R1, so minus 200 ohms I1 minus E1, so that's minus 10 volts, is equal to 0. That's the first equation. Now the second equation is going to be, let's write it in red. For the second equation we have plus E2, so it's 20 volts, and then plus I3, so it's 100 ohms I3, and then minus R1 I1, so it's minus 200 ohm I1 minus E1, so it's minus 10 volt, is equal to 0. So these are our equations. Okay, I'm going to circle them. Okay, my next step is to rewrite them. I'm going to write them with the same color. I'm going to divide everything by 10 ohms to just simplify the equations. So if I divide 150 ohms by 10 ohms, that will leave me with 15 I2, then minus 20 I1, and 10 over 10, that gives me 1, but it's 1 amp since it's volts over ohms, so it's minus 1 amp is equal to 0. The second equation, the 20 here and the minus 10 will give me a plus 10 that I'm going to divide by 10, so that will give me 1 amp, and then we have plus 10 I3 minus 20 I1 is equal to 0. And the last equation is I1 plus I2 plus I3 is equal to 0. Okay, again, so they look like simple equations. What I'm going to do is, for example, solve for I2 in the first equation as a function of I1, solve for I3 in the second equation as a function of I1, replace everything in this equation, and that will give me one equation with just I1. So the top equation gives me I2 is equal to 20 I1 plus 1 amp over 15. I'm going to leave it like that. For the second equation, solving for I3, so 20 I1 is going to go to the other side. The 1 amp is going to go to the other side, so it becomes minus 1 amp divided by 10. I'm going to plug both of these in this equation, so that gives me I1 plus 20 I1 plus 1 amp over 15. Then plus I3, which is going to be 20 I1 minus 1 amp over 10. All of that adds up to 0. So trying to simplify this, I'm going to multiply everything by 15. So I'll multiply everything by 15. So I have 15 I1 plus the 15, I'm going to get rid of it there, so plus 20 I1 plus 1 amp, and then 15 over 10, that's 3 halves, so plus 3 halves of 20 I1 minus 1 amp is equal to 0. Okay, just a little small algebra here. So I have 15I1, 20I1, and then I have 3 times 20, 60 over 230. So I have 15 plus 20 plus 30. So 65I1, let me make sure I'm right, 15 plus 20 plus 30. That's 65I1. And we have plus the I1 here, I mean the 1 amp here, and then plus minus 1.5 amps, 3/2, equal to 0. So I1 is going to be equal 0.5 amps over 65. .5 over 65, so multiplied by 1000, so I can write it in milliamps. So this is equal to 7.7 milliamps. Okay, now for I2, all what I have to do for I2 is go back to this equation. So I2 is 20I1 minus 1 amp divided by 10. So I'm going to do that. Actually, divided by 15, sorry. 20I1, I wrote the wrong equation. 20I1 plus 1 amp over 15. Okay, so times 20 so it is 76.9 milliamps. Okay, and let's do the last one, I3, which is going to be given, let's go another color not to confuse things. I3 is going to be by this equation. So I3 is going to be 20I1 minus 1 amp over 10. So it is minus 84.6 milliamps. Okay, now if you compare things, minus 84.6, that tells me the direction that was chosen for I3 is not really the way the current is actually flowing, and that's why we get the minus sign. But then if you add up, just for verification, 76.9 plus 7.7, you should get the 84.6. And that's what we have. We got all currents, so it took a little algebra. Okay, now this was one example. Let's look at some other examples that we might face. For example, this one. And they're asking us to find the current through R1. This is an easy question because we have only resistors in parallel. And because they are all in parallel with the battery, with the supply. So we know that the voltage across R1 is just 10 volts. And the voltage across R1 is given by Ohm's law. It's R1 times I1. So to find I1, it's as simple as VR1 over R1, which is 10 volts over 20 ohms, which is 0.5 amps. That's an easy question. Okay, now what about this question here? What if I have, see, it's very similar to the other question, but I have another source there. Again, you need to have a good focus. What's the voltage across R1? Let's do a little color in here to make sure that we understand this. Okay, the voltage here is the same here, same here, same here, same here. The electrical potential here is the same here, same here, same here, same here, same here. So the change in electrical potential across R1 is the same as the change in electrical potential across E1. They are in parallel, which means VR1 is equal to E1, and VR1 is like what we have discussed a moment ago. VR1 is equal, given Ohm's law, R1 I1. So I1 is just VR1 over R1, and in this case that's going to be 10 volts over 10 ohms, so it is 1 amp. Not that bad. Now here is an interesting question. How would the current I1 change if you open the switch? Kind of like remove this. That's very much like we don't have this. It should not change because the voltage across R1 is still the same as the voltage across the battery E1. So we should get no change. Now, what if we were asked to find the voltage across R2? Actually, the labels here are missing. This is R1 and this is R2. Should not be bad. Okay. Now we can work it out using Kirchhoff's rules. I'm going to use the colors. The currents are already designated. My minuses and pluses, it's missing here, but it's given in the rest. This is my plus for R2 and this is my minus for R2. Now since we are asked only about the current in I2, and since it looks like we don't have complications here in terms of having other resistors or anything like that, it might be very simple to do. So what I'm going to try to do is start in here, let's use another color, and go around that loop. And that might be sufficient for working out the problem. Just to make sure we are on the right track, let's finish our requirements. R2 I2, that's the voltage drop here. R1 I1 here. We'll worry about that later if we need it. Okay, now starting here. So the first item, let me choose another color so it's more obvious. Okay, so starting here, first thing I meet is the positive of E2, so we have a voltage drop, so it's going to be minus E2. And then from here I meet the positive of R2, so that's going to be minus R2 I2. And then here I meet the minus of E1, and so it's going to be plus E1. And then I'm back where I started, so this is 0. So in this case, E1 and E2 are known, so this is minus 5 volts, minus R2I2 plus 10 volts is equal to 0. So I2 is just equal to minus, actually, so I move this to the other side, so it is plus 5 volts over R2, which is going to be, in this case, 5 volts over 10 ohms, so 0.5 amps. That's I2. So in that particular question, what's IB? We found in the previous question I1 as 1 amp, I2 as 0.5 amps. Now, using Kirchhoff's junction rule, IB for this junction is equal to I2 plus I1. So IB is just 1.5 amps.